This is section 3.4, solving applied problems using two equations. And the objectives are to solve applied problems involving total values and the mixture using systems of two equations, and then to solve applied problems involving motion using systems of two equations. So it begins with the retail sales of sweatshirts. The campus bookstore sells college T-shirts. White T-shirts sell for $18.95 each, and red ones for $19.50 each. If receipts for the sale of 30 T-shirts totaled $572.90, how many of each color did the shop sell? So here is a little setup for this. It's basically a little table where you just fill in the missing numbers, and so we know that the price of a white T-shirt is $18.95, and the red one is already figured in there. And so also here, the number of white and red T-shirts has to equal 30. And then the equation, the second equation, would be $18.95 times W, the number of T-shirts, plus now we have the red T-shirts for $19.50 times R, and all this equals $572.90. $572.90. So $18.95 plus $19.50 equals $572.90. Okay, so now how do we solve the system of equations that we're looking at here? So let me just rewrite it here. W plus R equals 30. And to get rid of the decimals, let's multiply this equation by 100. So that then becomes 1,895 W plus 1,950 R equals 57,290. 57,290. Okay, so there are a number of ways we can solve this system of equations. Let's try substitution. And let's just say we solve this first equation for W. So W is equal to 30 minus R. So then we replace W in the second equation with this expression, 30 minus R. So we have 1,895 times 30 minus R plus 1,950 R equals 57,290. Okay, so now we multiply 1895 times 30, which is 56,880. 56,880 minus 1,895 R plus 1,950 R equals 57,290. Now we combine the terms of the R, and that gives us 55R. And then we subtract 56,000 880 from both sides. So that means on the right side, we only have 440. Subtracting this number, 56,880 on both sides. Then we divide on both sides by 55, and that means R equals 8. So 8 red t-shirts. And then from this equation, W equals 80 minus R, we find that the number of white t-shirts equals 30 minus 8, or 22. So in other words, the store the bookstore sold 22 white t-shirts and 8 red t-shirts. Again, you can try a different approach to this system of equations. Of course, the answer will be the same if it's done correctly. But so just try it out. Maybe use elimination. There would be another way to do that, of course. Graphing would not be a good idea because of the numbers involved. It would be very difficult to do, the scale and so on. So elimination or substitution either way, and you come up with the right answer. The next exercise is a blending problem. So blending coffee. The coffee counter charges $18 per pound for organic Kenyan French roast coffee and $16 per pound for Sumatran coffee. How much of each type should be used in order to make a 20-pound blend that sells for $16.70 per pound? So first let's define the variables, and so let's say that X would be the number of pounds of Kenyan coffee. I just make it Kenyan. And Y would be the number of pounds of Sumatran coffee. So that means that $18 times the number of pounds of Kenyan coffee plus 16 times the number of pounds of Sumatran coffee, we want to have 20 pounds that cost $16.70. And the other thing we know is that the total number of pounds, X plus Y, equals 20. From the second equation, if we use substitution, we can write that Y would be equal to 20 minus X. And then when you look at the first equation, let's multiply that by 100 to eliminate the decimals. So we get 1,800x plus 1,600y, and that is equal to 33,400. When you multiply 20 times 1,670. Now let's substitute for y the expression 20 minus x in the second equation. So we have 1,600x, 1800x, sorry about that, plus 1,600 times 20 minus x equals 33,400. So now we used the distributive property to eliminate the parentheses here. So we have 1,800x plus 32,000 minus 1,600x equals 33,400. Combining like terms, 1,800x minus 1,600x is 200x. And when we subtract 32,000 on both sides, then 33,400 minus 32,000 is equal to 1,400. Dividing both sides by 200 gives us x equal to 7 pounds. X equal to 7. And since y is 20 minus x, so y is equal to 20 minus 7, or 13. So in other words, what we need is 7 pounds of the Kenyan French roast, 7 pounds. And we need 13 pounds of the Sumatran. Again, there are different approaches to solving this system of equations. And again, I would encourage you to use your own approach just to try out different ways to come up with the answer. The next exercise is about investing money. And so we need to know a little formula here that you're probably familiar with. And that's how interest is simple interest is computed. And that is interest equals the principal invested times the interest rate times time, often measured in years. So in this example, it says Infinite Financial Services invested Jasmine's IRA contribution of $3,700 for 1 year at simple interest, yielding $297. Part of the money is invested at 7% and the rest at 9%. How much was invested at each rate? So here we have the money coming, or the interest coming from two parts, from two investments. And so here's the table, it's already set up. In this case, in this formula, I equals P times R times T equals 1, because we're told it's for 1 year. So therefore, basically I already set it up in this table here. Here's the first amount X, the second amount Y, and so the total amount is 3,700. So X plus Y equals 3,700. So that's the formula for the principal. That's for the principal. Now the rate of interest for the first amount is 7% for the amount X, and the amount Y is invested at 9%. And again, the time is 1 year. And so then the interest accrued from the amount X, the first investment, is 0.07 times X. And from the amount Y would be 0.09 Y. And the total amount of interest is 297. So 0.07x plus 0.09 y equals 297. So this is the equation for interest. So we're looking at two different equations. So again, this one is for the principal, and this is the formula for the equation for the interest. So let's rewrite it so it's a little easier to see how we go about solving this. So we have x plus y equals 3700, and we have 0.07x plus 0.09y equals 297. Okay. So again, let's just use substitution. It seems simpler to me here right now. And let's say that we solve the first equation for x. So x is equal to 3,700 minus y. So this amount for x we substitute into the second equation. So we have 0.07 times x, and x is 3,700 minus y plus 0.09y equals 297. Next, we use its derivative property to eliminate the parentheses. And 0.07 times 3,700 is 259 minus 0.07y plus 0.09y equals 297. When you combine like terms on the left side, we get 0.02y, and then we subtract 259 on both sides. That gives us 38 on the right side. Then we divide by 0.02 on both sides, and then y is equal to 1,900. And since x is equal to 3,700 rather minus y, then x is equal to 1,800. Yeah, that's 3,700 minus 1,900. It's equal to 1,800. So in other words, $1,800 was invested at 7%, invested at 7%, and the amount of 1,900 was invested at 9%. The next exercise is about mixing cleaning solutions. And so here King's service station uses two kinds of cleaning solution containing acid and water. Attack is 2% acid and Blast is 6% acid. They want to mix the two in order to get 60 quarts of solution that is 5% acid. How many quarts of each should they use? Okay, so let's call A the amount of solution A for attack and the amount of solution B for blast. And so the mixture is supposed to contain 60 quarts. So we can say then that A plus B equals 60 quarts. Okay. Now there's 2% acid in the attack solution, and there's 6% acid in the blast solution. And a decimal, that's of course 0.02, and this would be 0.06. So therefore we have 0.02 A and 0.06 B, and that has to equal 60 quarts times 5%, or 0.05. So 0.02A plus 0.06B equals 60 times 0.05 of the acid, and the total acid in that in the mixture. So let's rewrite these equations so we can work with them a little bit better. So A plus B, attack plus blast, equals 60 quarts, and then so that's the amount of solution. That's one equation. Then the amount of acid in solution would be 0.02A plus 0.06B equals 60 times 0.05. So the second equation is about acid. That's the amount of acid that we've got. And this is the amount of solution. Okay, so again we can use substitution, or we can use a different approach. Again, I think this makes sense to me here right now to use substitution. So we can solve the first equation for A. So A is equal to 60 minus B. Okay. Then we substitute for A the expression 60 minus B in the second equation. So we have 0.02, and for A we use 60 minus B, plus 0.06 B equals 60 times 0.05. 60 quarts with 5% acid. As we use the distributive property to eliminate the parentheses here, 0.02 times 60 is 1.2 minus 0.02 B plus 0.06 B equals 3. 60 times 0.05 is equal to 3. So then we have 1.2, and when we combine minus 0.02 with 0.06b, we get 0.04b equals 3. Now we subtract 1.2 on both sides. It gives us 0.04b on the left side, and on the right side we have 1.8. 3 minus 1.2 is 1.8. We divide both sides by 0.04. 0.04 divided by 0.04. So it means B is equal to 45. And since A is equal to 60 minus B, so 60 minus 45 is 15. So in other words, we need 15 quarts of attack and we need 45 quarts of blast to make a 60-quart solution that has 5% acid in it. The next exercise is about train travel, 2 trains. A train leaves Barstow traveling east at 35 kilometers per hour. 1 hour later, a faster train leaves Barstow, also traveling east on a parallel track at 40 kilometers an hour. How far from Barstow will the faster train catch up with the slower one? Okay, so let's think about this a little bit here, and let's make a little timeline that might help understand the problem here. So let's say this is a timeline for the slower train, and say this is t equals 0 hours. So here's the slow train. It leaves at t equals 0 hours, traveling at 35 kilometers an hour. So that's 35 kilometers per hour. Then here's a faster train, and it leaves 1 hour later. So here's 1 hour, and it travels at 40 kilometers an hour. 40 kilometers per hour. And so the basic formula is distance equals rate of travel times time. So again, we have a little table here for the slower train. D, the distance D equals 35 kilometers per hour times time. So D equals 35 t. And the faster train at 40 kilometers an hour, and that's times t minus 1. Remember, it leaves 1 hour later. So the distance traveled would be 40 times t minus 1. Now the distances must be the same, and that's an important observation here, because the question is, how far from Barstow will the faster train catch up with the slower one? So the distance both trains have traveled will be the same. That's a very important consideration in this problem here. Therefore, we can set the distances equal to each other. So 35 t equals 40 times t minus 1. So we set the distances equal to each other because they're the same. So that gives us 35t equals, using distributive property, 40t minus 40 times 1 is 40. And then subtract 35t on both sides. And so we have 0 equals 40 minus 35 is 5t minus 40, or 5t equals 40, or t equals 8 hours. So now remember what the question was. The question was, how far from Barstow will the faster train catch up with the slower one? And remember, the faster train travels 40 times t minus 1. So 40 times t minus 1 equals 40 times 8 minus 1, because t is equal to 8 hours. So that's 40 times 7, or 280 kilometers. The faster train will catch up with a slower train 240 after it has traveled 280 kilometers. Exercise 6 is about air travel. An airplane flies for 4 hours with a 20-mile-per-hour tailwind. The return flight against the same wind took 5 hours. Find the speed of the plane in still air. So let's say R is the rate of the speed in still air. Speed of the airplane in still air. So when we fly with a wind, of course we fly faster, so our rate increases, in this case by 20 miles per hour. And the time would be t, it would be 4 hours. When we fly with the wind, it takes 4 hours. So in other words, d equals r plus 20 times 4. When we fly against the wind, we go slower, so now our rate decreases by 20 miles per hour, and for 5 hours. So that means the distance flown is the rate, now r minus 20, times 5 hours. Again, the important observation is that the distances are the same. So therefore, we can set the distances equal to each other, which means that r plus 20 times 4 equals r minus 20 times 5. So using the distributive property, that means 4r plus 4 times 20 is 80 equals 5r minus 5 times 20 is 100. By subtracting 4r on both sides, we get r on the left side, and adding 100 to both sides gives us 180. So in other words, the rate of the airplane or the speed of the airplane in still air is equal to 100 miles per hour. And even though it was not stated specifically what the rate of the airplane is in terms of units of measure, miles per hour, it is implied because we are told that the wind speed, the tailwind, is 20 miles per hour. So everything is in miles per hour. And so then our final answer for the speed of the airplane in still air is 180 miles per hour. To develop proficiency with these types of exercises, I would recommend you do lots of them. There are a lot more in the textbook, and of course your homework exercises will have these type of problems as well. But with word problems, again, practice really improves your skills in dealing with them successfully. This is the end of section 3.4.